if you're watching this, well done. We're halfway there. Sorry I can't be with you today, but I'm going to tell you what you need to know. Hopefully you'll be able to get on with a bit of work, and the day is not a total loss. So, what I would like you to do, first of all, is put a title for today's work. What we're going to be dealing with today is equations with fractions. So please just put your title, equations with fractions. I will give you a second just to get that. Can you also please put down today's date and that we're doing classwork. Equations with fractions, really good topic to practice. It's something you're going to have to use quite a lot when it comes to physics. So we need to be really on top of how it works and be sure that we are really up to speed with it. So let's just start with dive in with a quick example, the sort of thing that you're going to have to answer. So a little example question is going to be something like 4x over 3 equals 7. Okay, nice question. We've only got the one fraction, which is obviously on this left hand side here. I'm going to change my pointer into a laser. Yeah, look at that. 4x over 3 equals 7. So what do we need to do? There's one general rule that you need to kind of be aware of when you're dealing with this type of thing, and that is you need to get rid of this thing. Whatever is on the denominator of a fraction, we're going to get rid of them before solving. So, in fact, what I'd like you to do is just put a little side note to that before we continue. So, if I go over here, I'm going to put 2 lines down here, and we're going to say get rid of denominator before solving. And we'll go through the different scenarios where you'll have to do that. Don't panic for now, but that is our general rule whenever we're solving an equation with fractions. We get rid of what's on the bottom. So, our rules for fractions for equations, is we do the same thing to both sides. Equations are, remember, like seesaws. If you take something off one side, you have to take the same thing off the other side. Currently, what's happening to my x are two things. It's being multiplied by this 4, and then the whole thing's being divided by this 3. And this 3 is the first thing we want to get rid of. So, what we can do that, it's currently being divided by 3, we do the opposite. So if I times both sides by 3, I show my workings to the examiner, what am I left with here on this left hand side? Well, we've just been cancelling fractions. If I times it by 3, that gets rid of this thing on the bottom. So that's quite nice. What I'm left with on the left hand side is just a 4x equals, let's follow the right hand side down, 7 times 3, 21. I've made up these numbers and they're not nice, but that's fine. We can still go through the process. This is then now finishing off the solving of an equation. We've got 4x's, we only want to know what 1 is, so I divide both sides by 4. And I get an answer of x on this left hand side, right hand side 21 divided by 4. Tell you what, you can leave it like this, 21 over 4. Fractions make life easier, believe it or not, they can help. If you really want to put that into a fraction, it's already in a fraction. If you really want to put that into a decimal, what's 21 divided by 4? It's going to be 5.25. Either way, your answer is correct. So that's our first example, and all we're doing is we're utilising this idea over here, get rid of the denominator before solving. The way we got rid of it, this was our denominator, is we multiplied by whatever it was. So let's, in fact, tell you what, why don't you box this? Let's have a nice bright colour. I don't have a very bright colour. Oh, that's a horrible colour. I can have a blue. Make sure you box this, googly eyes looking at it so you refer to it when you're going to do your looking through your notes, that's the first thing you're looking for. That's our general rule. Get rid of the denominator before solving. Let's go through a second example. Okay, the next type we're going to do is where we've got two terms on one side of the equation. So what I mean by that is we've got something like, again I'll make up the numbers, 2x over 5 plus another, I don't know, 4x. That has a value of 15. Again, no idea if it's going to work or we're going to get a nice number. Hopefully we will, if not it doesn't matter. Now, our rule applies. Our rule was we need to get rid of any fraction with a denominator. So as soon as we see that number on the bottom, that's what we need to multiply both sides by. But you've got to be careful here. On the left hand side, I've got two terms. Usually I would ask you to raise your hand at this point and tell me why there are two terms. The reason is because there's this plus sign in the middle. So it's separated by a plus sign. There's two different terms there. And then we've got just one term on this right hand side. But the rule still applies. We need to get rid of this thing being divided by 5. So what we need to do is we need to multiply both sides by 5. Quite straightforward. But just be careful to make sure that what you do with the left hand side is you multiply that whole thing by 5. That means that we multiply it with this first term, which gets rid of the 5 on the denominator, which is what we're going for, but it also multiplies with the 4. So, what happens when I times by 5? Don't worry if you wrote those brackets down, it's absolutely fine for them to be there. Well, my first term here just becomes 2x plus 4 times 5 is the 20, x equals 15 times 5, 75. Okay, let's just recap that again because that was quite tricky. What I've done, I've multiplied this side by 5, this whole side by 5, and I multiplied this by 5. I said to you, just to recap, that what that means is I need to multiply 5 by this first term, which means I get rid of that, and then also by this second term, which means 4 times 5 becomes 20, and obviously we've got the x there as well. So, unfortunately I haven't got nice numbers, but that's fine. 22x, if I put my x's together, equals 75. over 22. Answer done. Which actually does, I believe, equal 3.4. So x there equals 3.4. Okay, fantastic. Making good progress. We're only 9 minutes in. So I just want to show you one other situation that you may come across and how you're going to handle that. So the question that I want to do now is going to be our third example. We're going to use the same principles. And how do I move this down? Perfect. Example 3. The question I want to do now is something like x plus 2 over all over 3 equals x minus, I don't know, 4 all divided by 5. Okay. Hardest situation here. I think these come in the 57 star exercise, which I'm hoping some of you will be able to progress to. A little bit harder in that we've got two fractions to think about. Same idea, we need to get rid of these denominators, but now there's 2 of them to get rid of. We'll just approach that one at a time. So, if I'm going to get rid of this left hand side being divided by 3, I would go through the same process of multiplying both sides by 3. That's what gets rid of it. We've covered this a number of times. So what that then becomes is, well, this left hand side becomes x plus 2 is equal to, now if I multiply this right hand side by 3, in fact what I might do is I might keep it as 3 times x minus 4, remember it goes to the top of the fraction, all over 5. Hopefully you're seeing where I'm going with this. Next I need to get rid of this 5, so it's currently being divided by 5. What I want to do is I want to then times both sides by 5. I've used the wrong colour there, haven't I? Can I get rid of that? Keep things nice. Times by 5 and times by 5. So this left hand side, remember I multiply the whole of the left hand side by 5, it becomes 5 lots of x plus 2 equals, and when I multiply it on the right hand side it gets rid of this denominator, so it equals, oops, that's a 3, isn't it? Can I make it look like a 3? Yeah, 3 lots of x minus 4. Perfect. Okay, this is the type of equation that we have done before, but it's quite tricky, and the steps are this. Make sure you multiply out this bracket by multiplying the 5 by both terms. Same thing here, the 3 needs to multiply with both terms. So the first thing I'm going to look at is the 5 times x, 5x. Then the 5 times 2, good, I can hear you all saying it, 10. 3 times the x, 3x, and 3 times minus 4, be careful, minus 12. Okay, now we need to solve this equation. I've got different options. I need to take things off both sides, I need to add things to both sides, I need to make this work somehow. My choice would probably be, and I'm hoping some of you are spotting this, to take away 3x from both sides. Try and keep them positive if you can. So the result is, if I work down, 5x minus 3x, 2x, still working down, 10 is still there, still working down, that disappears in a puff of maths, and minus 12 is still there. Finally, or almost finally, I want to get rid of, or I'm aiming for, if you like, x is on one side, numbers on the other. So I don't want this 10 with the 2x, I want the 2x on its own. So let's just take that off of both sides of my seesaw. Take away 10 from both sides. 2x, that disappears, equals minus 12 minus 10. This is one you do have to be careful on. So easy to think that it becomes a positive. It's minus 12, take away another 10, minus 22. Brilliant, we're almost there. Divide both sides by 2, we want to know what a single x is, and finally, I've made up one where the numbers are nice, and x equals minus 11. So, quick recap. What have we done? And let's zoom out so you can kind of see it. That last one took up a bit of space on the page. Equations with fractions. First example, 4x over 3 equals 7. We wanted to get rid of the denominator before solving. Whatever that denominator is, we multiply on both sides. And then we found 4x equals 21, divided it to find out what single x is. That was quite nice. You'll have a few of them to start with. Second example. What you actually start with here is the bit that's in blue. 2x divided by 5 plus the 4x equals 15. Again, we still multiply both sides by whatever the denominator is on that fraction. So here we're timesing by 5 on both sides, but we needed to just be careful that the first 5 cancels with this fraction, that's fine, but also multiplies it with a second term. If there's something that's separated by a plus or a minus, you make sure it applies to both, and then 15 times 5 gives us our 75. Put our x's together and then solve to get our answer. Finally, and these are quite nice actually, this algebra you've all seen before, hopefully you'll be able to have a go at a few of these. X plus 2 over 3, x minus 4 over 5. I chose to get rid of this denominator first, so we multiplied both sides by 3. You can see then it's gone, but this 3 comes up here. Multiplied both sides by 5. You can see then the denominator disappears, but the 5 comes up here. From there, it's a case of expanding our brackets accurately, collecting like terms, and then doing the correct subtraction from both sides in order to reduce it to letters on one side, numbers on the other, and then we finish off by working out what a single x is. So there you go. Hopefully you'll be able to have a go at some of the questions. Now what I've asked for you to do is going to be, I want you to start looking at exercise 57. Exercise 57. Page 123 on your textbook, and then I'm hoping you might be able to progress onto, even if you get stuck, just move on. You'll be able to do some, I'm sure, 57 star on the next page. I think it's the next page. Yep. 124. Great, and I'll catch up with you guys tomorrow. Thanks for listening.